So everyone has their worksheet open. The thing is, it's pretty important to have everyone here, because otherwise people will come in, they'll be lost. They won't know what we're doing. Let's hear some reports. You guys can unmute some reports on your fly counts. What's the status of your fly count data? And then I'm going to put us into groups as we had it. And you guys can share your data with each other in your teams. But let's just talk first. How did it go? Does everyone here know how to anesthetize flies in general? Did everyone pretty much learn how to do that? Oh, thumbs up. Awesome. I see most of you are like nodding in agreement. That's great. Because I mean, it's fun to have lab skills, right? And that's a lab skill. That's a fun lab skill. How many of you like give me a word to describe that experience, 1 or 2 words or phrases. Somebody just popcorn, different people. Stinky. That's mine. Stinky. Come on, somebody.
Oh, dirty after. Even if after I showered.
You felt dirty after. So the smell lingered?
Yeah, it lingered. And like, I was just seeing flies everywhere, even if they weren't our flies.
Right. And the good thing, the comforting thing is that they're fruit flies. Remember, they're fruit flies. They're not like flies that live on dead rodents by the side of the road or, you know, other worse things. They live on bananas and, you know, fruit. So not as bad and disgusting as they might have been. So no one else has a thought? How about the feeling you get when you're like trying to get the flies out, like, or try to put the anesthesia in? What feelings come to mind?
It was a little stressful to get the timing right. That's
what I was looking for. Stress. Because if you don't do it right, what happens? Boop, the flies, they fly right out, right? Did anyone experience a little bit of that? Amazing. It's amazing. All right, cool. So let's get our worksheets open. I'm gonna share my screen, my other screen, just for a second. I see a chat. Let's chat. Who's chatting here? Yeah, Andres, they twitched, but they stayed alive, didn't they? All right, so you have your worksheet open. It should look like this. Share a screen. And my goal for you guys is to, you know, let's just go over the goals for the day. The goals are for you to finish doing this worksheet. Can you all see that reasonably clearly? I can make it a little bigger if that helps. Oops. Yeah, so statistical analysis, right? So statistical analysis is what helps us know whether a particular conclusion is something we should have confidence in. And also it gives us an idea of how confident we should be. And it puts a number on that, you know? So as you recall, we set up our crosses, and then by this time everyone has, hopefully gotten all the data. Let me just do a share of hands of all you guys. Like Andres, you can show yourself, Olivia, so I can see your hands and stuff. If it's possible to show yourselves, so we can all like be in class together. That's better. And don't worry if you're eating. I mean, I'm gonna be eating a banana myself in a few minutes. That's cool. All right, very good. So how many of you do you think you have enough data for your monohybrid cross, just the monohybrid cross? Enough data in your team? How many of you know that you don't have enough data? How many of you are not sure yet if you have enough data? Grace, can you raise your hand at all? I think she's stuck, frozen. Okay. So we'll share with each other and figure out first if we have data. Grace must have bad internet today. You all right there, Grace?
Yeah, I just got kicked out. Sorry.
Yeah, you're back. Do you think you have enough data for your monohybrid?
I'm not sure. I think so.
Yeah, we'll find out. And then for your dihybrid, do you guys Was it the same? Did you get the same? Did you have enough data for your dihybrid, do you think? Raise your hand. Okay, a few of your teams probably do. Okay, that's awesome. That saves a lot of time. And so you should have a table like this, and you will have, for the monohybrid cross, there will just be the two phenotypes. And what were the phenotypes? Can someone tell me? So wild type. And what was the cross that we did? Help me out. What was the Apterus? Was it Apterus? Thanks, because I couldn't remember for sure if it was Apterus. It was like 3 weeks ago, and so there were actually some different ones I think for the dihybrid. Okay, so you may have done males, females, but the most important would be the observed total. You're gonna double check your data in your teams. All right. So let's do that now. Let me just set up teams. I was gonna look on my phone for the teams. Let me see if I can do this live with you guys. This will take probably 3 or 4 minutes. Let's see. So so breakout rooms. All right, I'm going to set these up. Whoops, where did it go? Where'd the little window go? Breakout rooms. Wonderful. It's not showing up. Oh, come on. You got to give me a break here. Oh, here, it's hidden by the, all right, so I'm gonna assign manually. Oh, let participants choose room. Should we try that? You guys know who your partners are? Let's try this. I don't even know how this works. Let's just try it. Oh, it says create rooms. How many teams are there? 4, right? 4, 1, 2, were there 5 teams? 5 teams, I think. Help me out here, you guys. Were there 5 teams?
I know there was 3 teams in our room. I don't know about the other room,
It was
but
3
there's
and 2. All right, maybe I'll just look this up on my phone manually. I took pictures of all the of the board, which had the teams on them. What was the last date? What was the date of the FlyLab that we started? Does anybody have the date of that? Oh, here it is. I got it. Oops. Yep, I got the teams. Okay, Lily, Andres, Kawana, and Jay. So assign manually create. Oh, wonderful. Assign. Okay, Lily, Andres, Jay, Kawana. Is Kawana not here? Okay. That's that room. All right, fine. Fine. For room 2 will be Jordan, Eden, Malachi, Olivia. All right, that room is set. Room 3, this is actually pretty easy. Room 3 is Allison, Grace, and Ivana. Allison, Grace, and that's all we have. Okay, and room 4 is assigned is Jean, Colin, Hannah. Hannah, Jean, Colin's not here. And 5 is James, Sophia, Isabella. Whoops. Assign. Oh, what happened? James is not here. Sophia and Isabella. All right, well, this is weird. It's not letting me add your names. The names aren't appearing. So why is that? Oh, maybe it's just whoever's left. Oh yeah, there it is. James, Isabella, Sophia. It appeared now. So I'm going to open up the rooms. You guys should share your monohybrid and dihybrid data with each other. All right. Whoever has the data, I'll give you guys, I don't know how long it's going to take. Maybe, should I give you like 5 minutes? I'll check in at 5 minutes. I'll just go to each of the rooms and make sure you guys are all right. All right. So share your data for now, and then we'll go through the theory behind the chi-squared together as a group, and you can do your data manipulation. Okay. So I'm going to open up the rooms. And if you have extra time, just stick around because we'll be popping back together afterwards. All right. Thanks, guys. Share data time.
Oh,
You guys are done, right?
yes, we're done.
All right. I will announce for people to come back. I was actually looking to see on Canvas. I think one of the chi-square sheets. Did you get a chi-square sheet that has the chi-square table in it?
We saw one in the chi-squared handout.
Where is that? I'm looking for it on here. What week is it under?
Let me
Chi-square.
check.
Finished counting flies, Carolina 3-point, dihybrid, DNA transformation. My goodness.
It was under week 5.
Oh, I know. It's a link. That's what it is. All right. It's a link under assignment. I think there's a link there. Yeah, chi-square handout. Fantastic. All right. I was like, why can't I find this thing? All right. Great. So everybody's back. Fantastic. Everyone has data. So I'm sharing my screen still, I believe. Am I? Yes? No?
Yes.
Okay. So so the chi-square handout looks something like this. And whoops, right here. So let's start at the beginning. So you have, hopefully you have a table that looks something like this, where you have your phenotypes, the expected ratio. It's going to, oh, the Canvas link doesn't work. I was going to have our TAs join us. Canvas link doesn't work. Would you like to see our TAs again, you guys? Yeah? Let me send them the link. Hold on, just take a second. Zoom. I think if I click that, it will allow me to find this link here and copy it. Oh my goodness. Why doesn't this work? Copy. And give me 1 second. Oh, come on. Okay. Even with two screens, it's not enough room to do all the stuff I want to do here. Okay. Okay, Sarah and Joe will stop in shortly. So all right, let's go back to where we were, and why does that keep popping over there? I don't like that. Okay. So just looking at your data, let's just focus on the monohybrid, and here comes Sarah. Let's focus on the monohybrid. Does it look like about 3 to 1 to you guys? Yeah, on the totals column. Lily, what do you guys have? How many wild type and how many mutant?
Let me check. Hold on.
Hey, Joe.
Made it. Yeah, the link in the text chat worked.
Yeah, right. For some reason, there's this bug, right? That you guys can't get through Zoom.
I'm in here now.
So right now we're just looking at our data. Lily, I asked this, I don't know why I picked on Lily, but what was your data? I'm sharing screen for the observed total of wild type.
We had 13.
13.
Or no, sorry, 66. 13 after
66 and 13. Yeah, that's not
Wild type.
way off, right? 66, 13. What
It's
about
like 1 to 5.
Yeah, it's not exactly 1 to 4, but 1 to 5 is just one numeral off. It's not like it's 50 times off or something. So we're going to use statistics now to figure out how confident you can be that that result is something you would expect by chance, 80 or 90% of the time. right? Or 95% of the time. That would happen by chance. So in other words, nothing weird or funny is going on. You see, I'm just using plain English to describe the statistical analysis, why we're doing it. And so you can actually put a confidence level on the fact that, okay, this number that I got it's expected. It's sort of like expected with randomness thrown in, right? Cool. Malachi's here. Did you miss the group discussion?
No, I was in the, you're talking
were
about
in
the
there.
breakout rooms?
You were in the breakout rooms. All right. Everyone has
Yeah,
data
sorry.
now? Does everyone have
I
data?
joined a couple minutes late because I was on Zhang's link by accident.
All right,
I
that's
could,
cool. All right,
yeah.
so does everyone have the data for the monohybrid at this point? All right, and so why does this stupid thing keep going over there? It's so annoying. Hey, Sarah's here too. And Sarah's home. I don't think they have fireplaces like that here at Gordon College that are so nice.
Yeah, I got home early this morning.
Really?
Yeah.
Wow, congratulations. You made your escape.
Yeah.
Oh. So yeah, I just wanted to say with you guys that it's been awesome having you as my TAs, and I think the students really appreciated you guys being around, and it's wonderful seeing everyone's face, honestly.
Mhm.
Having the masks on, it's not quite the same. James, I know your face. I've seen it before. But thanks for wearing the mask. You know, if you think you might be under observation, you should still have your mask on, even if you're home. My sister teaches elementary kids, and one of her kids tested positive, but luckily they didn't have close contact. It was 10 days ago on Monday, I guess, 10 or 11 days ago when she last had close contact. But that's scary. So now they're being tested and stuff. All right. All right, so let's do this. This is the worksheet. Okay, we got to go to the chi-square handout to do the test. So what's nice is it actually leads you through a sample calculation, and so you have your expected, totals. Really, the totals is what you really want to focus on for that worksheet too, right? You have your totals. You add them up for your total number. And then how do you get this, How do you get your expected total? Well, you take 70 and divide by what? Someone help me out. What do I divide 70 by? What do we expect? A 3-to-1 ratio? How many total parts are there in our Punnett square of a 3-to-1 ratio? Yes, thank you, 4. All right. Divide by 4, and that's the number that's going to be here. All right, and it may not be an exact number, like even it might be a fraction of a half or a quarter of a fly, but that's fine for the statistical analysis. You need to do this now. You need to get your total, and you need to fill in the expected column. So if this is one part, then you just take this, multiply by 3 to get this number here, right, for your expected column. Observed, expected. And actually, you can use this worksheet right here. You can cut and paste this. Let me get rid of these little symbols. You can cut and, once you do your calculation here on this chi-square handout worksheet, you're just going to use 1 and 2. You're going to use the first 2 columns because you only have 2 phenotypes. Do your expected ratio, male, female, total, expected total, and then we'll move on to the next step. Does everyone know what we're doing here? So work on this chi-square handout and get your expected totals. It should look something like this when you're done.
How do we do the expected?
So the expected, I'm not sure this is correct the way they did this, is it? All right, so the observed is what you actually observed. Your expected is a quarter of the total, right? Because the ratio you expect is 1 to 3 a quarter of them, of the total of 70 in this case, is 70 divided by 4 is 17.5. And then to get this number here, you multiply that times 3. 17.5 times 3. I think this is a mistake. My gosh, that's really funny.
Dr. Story, where is the chi-square lab hand? I don't know where that is on Canvas.
The little table.
Yeah,
here.
I'm wondering as well.
Hold on, we'll get there. We'll get there. What are you looking for? The chi-square. Oh, lab handout. It's a file linked under the assignment for worksheet 2. So go to Canvas and go to modules. Go to the worksheet 2 assignment. Click on that, and then you're going to see the chi-square lab handout here. Worksheet 2 here.
Yeah.
And background information, including the full table of p-values and stuff. So that's where it is.
Yeah, thank you. Found it.
Yeah. I'm gonna open up this one too. I hope you look through this. This is actually a really helpful handout. So observed, expected, p-values. Okay, yeah. So let's go back to the Word document again and check this out. So let's see. I want to show you one other thing that I have on my computer that might be handy. I mean, I suppose if you want, you can go ahead, but let's just try to stick together and go through it one time and get it all done correctly. So I'm going to find this 5106 lab, Drosophila info. Check it out. You guys like Excel? I know you do. It's a useful program. And why does this thing keep appearing over there? All right, so here is my Excel sheet calculator that I made a number of years ago, just to show you guys something. So, all right, so someone give me your data. It was wild type, and what was the phenotype again? It was Apterus. All right. Observed, Lily, what was your observed total?
For wild type, it was 66.
66.
And for Apterus, it was 13.
13? 14? What was it?
13.
13. Boom. Aha. So basically what this does is the expected is, why isn't it showing the formula? Oops. Oh, this is interesting. D5. This should be this plus this divided by 4 equals this plus this parentheses. You guys see what I'm doing, right? Divided by 4. It shouldn't, those numbers are just manually typed in. That's a lousy spreadsheet. Now this one, right, should be this value another parentheses times 3. Watch this. Oh shoot, I messed that up. This one equals this one times 3. There we go. All right. All right, let me go back. So if you'll notice, it does the subtraction of observed minus expected, observed minus expected. Let's go back to the chi-square worksheet and put in the data. Okay, 4 and 31. Let's see if we get 4 and 31 here. 4, 31. I'll say 31, 4. Wow. 8.75, 26.25. Oh, wait. Oh, sorry. I did the wrong numbers. 8 and 62. 8 and 62. 62, 8. 17 and a half, 52 and a half. Is that what we have here? Yeah, there we go. All right, so as you go along, you've got, just want to pause here and ask if you have questions about this expected column. Are you all set? Jay, are you all set? You're not making any movements. I know you didn't get much sleep, so I want to make sure you're keeping up.
I'm just a little confused.
All right, all right. So, so what do you have for your numbers? For your total observed numbers? What do you have? And it's is it vestigial or apterous?
After
Yeah, apterous. Okay. So what was your total observed apterous flies? Oops.
I'm a
Sorry.
little confused on how to get the observed. Oh,
So do you have this chi-square handout sheet open on your computer?
yes.
Okay. So go down to here. We have two phenotypes. We have wild type. We have apterous. No, yeah. All right. And so the expected ratio is 3 to 1 based on a traditional regular Punnett square. And so you guys have numbers. Your team has numbers. You're in the groups with Andres and Lily. Yeah, so this is, I keep asking you what your numbers were. Wild type was 60.
66. Oh, yeah, 66. And then after us was 13.
66, 13. All right. So now the total of 66 and 13 is 79. Do I have those numbers correct? All right.
Yeah.
Jay, are you keeping up now? You see what I just did? Is that all right? So these are the total flies, and this is the actual numbers we got observed, right? So now the expected is going to be, it's going to be 79 divided by 4, all right? A quarter of the total we expect. That's the expected number for the total of 79. It's going to be around 20, I think, right? 19.8 or something like that. So do that calculation with your calculator. 79 divided by 4. 79 divided by 4. 19.8. Or 75. We'll just call it 75. 19.75. And then you multiply that times 3 because it should be a 3 to 1 ratio like we saw over here. Times 3 equals 59.25. And this total adds up to 79. 59.25. All right, everyone else has different numbers. So now the next column, you subtract these two. You just subtract observed minus expected. All right. So 66 minus, oh shoot, I did that backwards, didn't I? 59.25. So somebody stop me when I screw up like that. So this should be the 3, and this should be the 1. 19.75, right? I did it. You could have done it 1 to 3, 3 to 1. It doesn't matter because in the end, we're just going to add that up and divide by the expected and so on. It'll just all be the same number in the end. Okay. Jay, are you confused now? I did it. I've got these numbers here. So
It makes sense
it makes sense?
until we get to the tie. Yeah.
Yeah, well, all right. So 59.25 minus 66 is minus 6.75 minus 6.75 and 19.75 minus rather observe 13 minus 19.75 minus, oh, it's the same number. Does that make sense? Why would it be the same number? Is that right, or did I screw that up?
I think
I
the
think
first
for
one
what-
is
Yeah, should be positive. 66 minus 59.25 is 6.75,
There
not
we go.
negative.
Yeah, thanks. All right, so now we take 6.75 and square that. And you get 45.6 basically, right? 45.6. 45.6. Let me go back to my Excel sheet for a second. Oh, well, let's just keep with that. We'll stay with this. I don't want to confuse you guys too much. So, so now, what does this mean? This is squared, observed minus expected squared, divided by expected. This one. So 45.6 divided by 59.25 equals 0.77. 0.77. So now we have a small number again, and these are the numbers that are going to give us our chi-square that we're going to look up on the chi-square chart. So this one is 45.6 divided by expected 19.75. Ooh, 2.3. Is that what you guys got? How are you guys doing? Did I do the numbers right? All right, I'm trying to see on my old, so wild type, sepia, total, expected. Oh, I see what I did on this worksheet. All right, so so now what do we do? So we add these together. 2.3 plus 0.77 plus 0.77, 3.07, 3.07. Okay, that is our chi-square value. There it is, 3.07. And now you're going to say, well, what do we do with that? So, so here we have the chi-square value for this example, 6.88. Let's talk through that. So our experimental chi-square value, 6.88, and it says 1 degree of freedom. What is this degree of freedom business? It has to do with how many categories there are, and you subtract 1. So in this case, there's 2 categories, vestigial wild type, and you subtract 1 from that. That gives you your degrees of freedom. This is a statistical terminology. But if you think about it from an intuitive standpoint, like if you have lots more categories, like many categories, you're going to end up with like a bigger thing added together potentially. And so you have to factor that number of categories thing into the table that you're going to use to look up your statistical result of the chi-square analysis, right? So the confidence interval, the confidence of your results. So there's a full table provided in this other handout, which I will open up. Oh, I thought I had it here. Thought I had it. Canvas. Oh, this one, yeah. So this one. So this is the larger chi-square table, and the The little part up here, this little portion is reproduced in the Word document that we were just looking at. P equals 0.05, P equals 0.01. Let me go back to this. P equals 0.05, P equals 0.01. Sorry, this part of the table is reproduced. So what do we do with this number that we got? This number that we got up here, where is it? Down here, 3.07 with 1 degree of freedom. So I'll do it together. We'll look at this together. You can look at it on this chart, on the simple chart. 1 degree of freedom, right? So we're just focusing on this, and our p-value is, whoops, our lookup number, our chi-square value is 3.07. 3.07 is actually to the left on this table. It's actually going to be a p-value bigger than 95%. So we have to go to the other table. All right, so you'll see, oh, wait. Yes. All right, so here we go. So what this means is, okay. Yeah, it's between 3.84 and 6.63. So that means our confidence interval is higher than 95%. So the chi-squared value is high. So that means, so this actually means that our result is funny, is we don't expect this to happen 95% of the time, right? So we do not have 95% confidence in our test. So let's go to this other chi-squared value. So this p-value here is the cutoff for what people call statistical significance. P equals 0.05. So 0.05, if you take your calculator and go 1 divided by 20, that's 0.05. 1 out of 20 times, right? P equals 0.01 is 1 divided by 100, right? 0.01. That's 1 out of 100 times. So 1 out of 100 times, so between 1 out of 20 times and 1 out of 100 times, somewhere between there, because our value is a little bit higher than, oh, is it higher than 3.8? Hold on a second, 3.8? Yeah. Our value was 3.07. Ah, okay. So our value is actually lower. So wait, I said that wrong, you guys. All right, so my goodness, this is confusing even to me. So your value is smaller than 3.8. So you're to the left. So you would expect this result to happen between 1 out of 20 times by chance, or what's 0.2? 2/10. 1 out of 5 times by chance. So this is not an unusual or unexpected result, right, you guys? Your p-value, your p-value is down in this range. If you see your p-value up in this range, you have the large chi-square value, that means something weird is going on, because if you think about it, you added up all those differences, it gave you a big number. That means your numbers are different than what you expected, right? And the significance level of that is given by these chi-square tables. You have to have a lookup table, and you have to use the right degree of freedom. And so your Lily's group's number falls to the left, the smaller number side of this. That means between 1 out of 5 times and 1 out of 20 times, you would expect this to happen by chance. So that's fine. That's okay. If it's greater than 3.8, you'd say this result will only happen more than 1 out of 20 chance. Maybe 1 out of 50 times would you ever expect to see this by chance. If it's in this range, 6.6, you'd say only 1 out of 100 times did this happen by chance. So this probably isn't by chance. There's probably something funky going on, right? And there's where you reject your null hypothesis. Yeah, this is fun. See how I get confused by these charts, because I only see these every once a year. But it's not too bad. It's not too bad. This is what statistics are for, to help you have a degree of confidence in your results. So now if you go back and you can take this result that you guys calculated, and you can do the following. You can do it like, whoops, let me shrink it down a little bit. You can do a screen grab like this. It says show your calculation. Go to FlyLab worksheet 2. Show your calculation. There it is. You just paste it in, right? See
Is
how
it
easy that
okay
is?
if we do it on paper and then take a picture of
Yep,
it?
you can do it on paper and take a picture. You can do that. Absolutely. So calculate and record the chi-square value. It says on paper and photograph. Yeah, so you can do that. So calculate and record the chi-square value on paper. So now you could do something like this. Like this. Like, then do a little explanation. Our value 3.07 is lower than the P equals 0.05 column, meaning, and now I'll leave it to you to describe, what that means, right? So the key is to show a little bit of understanding in your explanation and put it into your own words. Like, what does it mean that our p-value is lower or higher? Now, some of you guys you're gonna have different numbers than that 3.1. Or obviously, you're gonna have different numbers. And what would it be helpful for you guys to go into individual groups to work on your calculations at this time? Why don't we make sure everyone is fine in the group? And Joe, I'll put you in. Oh, how can I do this? Open all rooms, add room. You're here, but it doesn't say, whoops. I wonder how I can put you into a room. Let's just try it. So speak to me, guys. What do you think? Are you doing okay individually? Would it be better to do this as a group or in individual rooms?
I think I'm doing fine individually, but if we want to go in groups, that's fine.
Yeah, maybe double check with everyone, and then I think you can just come back when you're done, when everything's working fine, everyone's all on the same page. And then we're going to go to the dihybrid cross and do that one. So I'll set up the rooms, and we'll see what happens. All right. Yeah, so Joe and Sarah, you guys, I can now assign you to a room. Let's see, I'll stick you in the really small rooms. I'm going to assign you to room 3, Joe. Is that all right?
Yeah.
It's not working. Why isn't it working? Oops, what happened? Oh, there you go. And I'll stick you in room 5, Sarah. Oh man, there's a glitch here. Sarah assigned to, oh, there it is, room 5. Bye.
At Actor Story,
How are they doing?
I think they got it. It took a
What?
second. They just had to like think through what the numbers meant, but they're good.
Exactly. Let's give people another minute or two to get back.
Yeah. If you could clarify for them, just like, or like everyone, because if my group wasn't sure, a lot of people probably weren't. Just like what degrees of freedom means and like what the difference is and how you
we'll-
would pick your number.
We'll do that again. Mhm.
Yeah. Okay.
Just come back when you're ready. I'll go back to that big Edvotech chart. I'm still screen sharing, aren't I? Sarah, am I still screen sharing?
No, it's just your face.
Oh, it is?
Yep.
So weird. Just my sad face. Oh, that's right. There's a screen share. All right, I'm learning the system here. Room 2 and 3 are still working. Was anyone with Allison and Grace? No, Joe, you weren't?
I was with Hannah and Johnny.
I'll be right back. That'll mess things up. I'll let them finish up. They're having a party in room 3. It's actually, in a way, the Zoom session idea for doing the data analysis, it's almost a better way to like make sure everyone is following along, no one is falling behind and everything. And plus you're getting the work done, right? All right. So my in-laws in Pennsylvania, they live down in Chadds Ford. They go to this Amish store. They get me this stuff. It's called Sweet and Crunchy Blend. And honestly, I could eat this whole box like in 2 days, you know, all these nuts. I just love them. It's so delicious.
What store is it?
It's the Amish store. I'm forgetting exactly where it is. It's like on the way to Lancaster, but it's like maybe a half-hour drive. I would know the name of it if I heard it. You ever go to those stores?
There's lots of different ones.
Oh, there is?
Yeah.
It'll come to me. I'll probably remember it while I'm not thinking too hard about it. Let's get everybody back. We'll work together. And answer questions. I'll go through this chi-square table again just to make sure you understand this degree of freedom thing. What is it? It's Dutch way. I think Dutch way, is that it?
I've never heard of that one.
All right.
Nearby. What part of Pennsylvania you talking about?
We're talking between the Brandywine River area, like just north of Delaware, and in like Lancaster, off to the west a little bit. You're from Philadelphia, is that right?
Yeah.
I don't know if there's a lot of Amish living in Philadelphia. They're
We have
more
an Amish market, but it's like not the one you're talking about.
yeah, no, I'm sure it's different. This one's like in the farm area. All right, ladies and gentlemen, are we all back? We're all back. Okay, great. How did room 2 and 3 do? Because all the other rooms have been here for a second. Are there any lingering questions?
We're good.
You got it? You got it figured out? So,
Dr. Sorry,
again,
I think our group is still a little confused on what our value means.
right. So what was your value?
3.06.
Ah, okay. So it's to the left of this value. Now, notice can you see my arrow here?
Mm-hmm.
I'm focusing on the, come on, okay. I'm focusing on the 1 degree of freedom row. And again, you choose which degree of freedom you have based on the number of categories in your analysis. You had 2 categories, so that means 1 degree of freedom.
Mm-hmm.
And again, you'll notice that as you go down the chart, these numbers get bigger with more degrees of freedom, which makes sense because if you have more categories, you're going to be adding more things together, right? You're going to end up with bigger numbers just by the virtue of the fact you have more things to add together. And yet still you'll have the same significance levels, but with bigger numbers. So we're just focusing on 1 degree of freedom, and your number is to the left of this column. It's in this area down here. You'll notice that these numbers are getting smaller as they go down here. So a small number, if you think conceptually again, means that the difference between observed and expected is smaller. There's less of a difference between what you would have expected and what you actually saw. And that means you would expect that. That's what you expect to happen. That's the normal result, not the weird result. That's the expected result. And then the different columns are basically saying, well, how often would we expect this, all right? So very rarely would we expect such a small p-value, basically the exact number, hardly any difference. We would only see that about 1% of the time, right?
So that's a 99%.
Not rejecting the null hypothesis, right? So if you're on this end of the chart, this is expected, but it would be rare that you would see something this much of the time. So
Yeah.
you would expect to see something at least. So this would happen 99% of the time. You'd have a number like this, or how do you put this? This is confusing. So
Yeah, I'm still confused.
it is a little confusing to explain. So small differences are fitting your data. Usually you don't get a number that the difference is that small. Usually you get something that's, say, between one of these columns, right?
So
If
for
your number-
example,
Yeah.
sorry. For example, if your data matched up the 3-to-1 ratio like perfectly, it would be in that
It'd be like
0.99
0.
column.
Yeah.
Got it. Okay.
Like that's what that means. And anything to the left, so anything to the left, anything down here matches your hypothesis, and these match it really closely. And so the significance value of this is that's there's no difference between what you expected and what you observed, right? With
So as
flies,
it pertains to
flies, you're not going to usually get such a close association, especially with these amount of numbers. But if you
human error as
gathered
well.
more data, like think about this, if you collected your flies and pulled the data from all the high schools and colleges from the entire country, so you had ginormous amounts of data, can you see that your number would get more and more and more close to the expected 3-to-1 ratio?
Yeah.
So eventually you'd end up getting really small p-values like this.
Mm-hmm.
And that would give you extreme confidence in your hypothesis, the 3-to-1, is actually real.
But with smaller pools, there's like less of a
There's more
population.
variation. Yeah, there's more variation. And so then you can rely on this chart to give you and say, okay, we would expect this amount of variation to occur 1 out of 20 times. We would expect this amount of variation to occur 1 out of 5 times.
So since our value is behind the 3.841, it's like fits within that
between those two
confidence level. So as long as it's under the 3.841, we're good. And if you would be over, then
yeah, if you're over it, right? If you get even with this small amount of flies, whatever, if you're over that, that's a rare thing. That would only happen if it's over 6.6, that means that amount of variation would only happen 1 out of 100 times.
Which would indicate you probably did something wrong.
That
Right.
You have to go back to your hypothesis or your theoretical framework or your beliefs about Punnett squares and genetics. Something is funny. Something funny is going on.
Or just human error, right?
Most likely in this case, someone didn't count the flies properly, or they didn't, there's something happening. Maybe it, not in this mutation, but there could be something with maybe the temperature of the incubator where the phenotypes don't survive if they have the wingless, they don't survive if the temperature is below, let's say 20 or something. And then there's just no, you have a very vast underrepresentation, you get a big observed expected difference, you get this really big number and you say, hey, something weird is happening, you know? So there's where you reject your null hypothesis, rejecting
If you're over.
the sort of expected result.
And if
And
you're
that's when you-
under, then you accept the null.
Yeah, you don't reject, no, you don't
Okay.
accept it. You fail to reject it.
Oh, you failed to. Oh, yeah. Okay.
It's a slightly
Bringing
different
me back
concept.
to high school statistics.
Slightly different concept, yeah, because it's like saying we proved something. No, you failed to disprove it.
Yeah, exactly.
Right? Yeah, that's a better way of saying it. Awesome, thank you so much for the questions, guys.
Sure.
All right, let's go back to the oops, Word doc here. And we got to do our so let's see, where are we? 1 degree of freedom, null hypothesis. Basically, you're filling all this in, right? Chi-square, reject, different kinds of experimental error. You just have to use your imagination there. You can fill in experimental errors that could have accounted for the difference. I just mentioned one, potentially, but there's others that you could imagine, especially with Apterus, with wings, because maybe that causes them to, something happen with survival or something like that. Okay, dihybrid, and you can do that later. You don't have to do that right now. Okay, parental phenotypes. What were they again? So I looking on my phone at the photos, I noticed there's 2 sets of dihybrids. There is either the, not that one. It's either the
Do you want me to list them off?
Apterus. Well, it's either Apterus sepia or whoops, or vestigial ebony. Did you have vestigial ebony or Apterus sepia?
Yeah, we did ebony body, normal wings, then we have black body, normal wings, ebony body, vestigial wings, and then black body, vestigial wings.
Ebony vestigial, right? Ebony
Yeah.
vestigial. So you need to fill in 4 phenotypes dihybrid. Is this? It was vestigial plus black. So there's basically 4 categories. Unfortunately, in Dr. Zhang's did the Tuesday night session this week, and some of the groups only had 2. They only listed like 2 phenotypes for the dihybrid. And I'm like, oh man, they proved that they did not understand what the heck they were doing. So hopefully you guys got 4 different kinds of flies. Yes? Yes, I see nodding in agreement. Okay. And so you're going to fill these values in, and then you're going to go to the, and this is just your data sheet. You're going to go back to that other worksheet, the chi-square worksheet. Whoops.
Do you want me to give you our data?
Well, everyone has, have you shared data yet on this? Did you share the data in your group?
Our breakout groups? Yeah.
They all have data. You all have data. So observe, this is the key. So it's wild type, vig, black body, veg plus black body. All right, observe, expected. You do this whole thing, you get your number. I want you guys to work on that calculation just like we just did, and then when you get your result, let's see what it is, and then we'll talk through the chi-square chart again, the table. Does everyone know what they're doing? You're working on the calculations? Do you need to work as teams, or are you good on this on your own?
Would the ratio, so this is the 9:3 to 3:1 ratio.
Oh, yes. So
would it
wild
be,
type. All right. Is that right? Remember this? So
Yes.
observed, this one should be the biggest, these two should be intermediate, and then this should be the smallest number, hopefully. But your total is your total, and you subtract each one. Well, your expected is so let's see if I have, make up some numbers, 60, 22, 28, 8, something like that. I just made those numbers up off the top of my head. I'll add them up now. I'm adding up my fake numbers. 60 plus 118. Okay, so Jay, what number goes here? $118 divided by what?
Sorry, can you repeat that?
So expected total. The expected for all my total amount of flies, 118. What number goes in this row right here? You can just tell me the math. 118 divided by,
I'm assuming divided by 4.
oops, nope. That was before because we only had a total of 3 plus 1 things, right? Now I have a total of 9 plus 3 plus 3 plus 1. How many squares in the Punnett square is that? It's a 4 by 4 divided by 118 divided by 16, right? It's 1 out of 16. 1/16. Or you could say 118 times 1/16. Times by 16. Oops. That's 7.3. Oops. 7.375. And then I multiply that times 3 to get this number. Times 3, 22.125. See that? Does it make sense, Jay? And then I multiply this 7.375, or I could just take this and multiply this times 3. Again, times 3, 66.375. Do you see that this is the expected based on that number? So this is 3 times, this is 9 to 3 to 3 to 1. This is 9 to 3 to 3 to 1. The ratios here.
Just to be clear, when you got the last expected number, you multiplied it?
Say that one more time. You broke up a little.
I'm confused on how you got all the other variables besides the first one.
So you understood the 7.3. That's 118 divided by 16. 1 second. Where's there? Okay. So it's 118 divided by 16 because the total squares in the Punnett square, if you will, the total of all of these, this is the ratio, 9 to 3 to 3 to 1. All of those added together equals 16. And that comes from the original Punnett square, which is 4 by 4. There's 4 different gametes for each parent because they're both dihybrids. So it's yeah, it just harkens back to the old Punnett square. I think the chi-square handout here shows that. Dihybrid, whoops. Monohybrid, maybe it just shows a monohybrid. Sorry, it just shows a monohybrid. But anyway, so this is the one, which is 8 that I observed. But I would have expected 7.3 based on the total of 118. So it's 118 divided by 16 to get that value. And then to get this value, I just take that and multiply by 3, right? Because it's 1 to 3 here. And then from here to here, I just multiply by 3 again. 3 times 3 is 9. So 22 times 3 is 66.375. And then if you add all these up, it all adds up to 118. Does that make sense now?
Yes.
Great. And then it's a matter of just doing subtraction. So use your own data. Don't use this made up data that I did, but use your own data. Get your observed minus expected, multiply it by itself, that's square it, and then divide that value by the expected. And then you add all 4 of those together and you get this number down here. Little calculation time. Do you want to go in groups and make sure everyone's on the same page here? Let's do that. All right, open the rooms, back to the rooms, and yeah, we'll see if everyone's on the same page. Isabella, you're still here. 40.6. Divided by 0.612. Plus plus 1.89. Hey guys,
Hello.
how did it go?
Good.
Wait, I'm gonna do the 9 out of 16 is 56.3. 3/16 is 18.8. 18 point. I'm filling in my chart. See that? 18.8 divided by 3 is 6.3. 6%. Yeah.
I rounded my percentages to whole numbers. Is that okay?
Yeah, I mean, that's reasonable. You just don't want to have huge, long trailing.
Okay.
I mean, in terms of percent, it's arbitrary because this isn't based on data or significant
Yeah.
figures. It's basically arbitrary, what you call that, 56, 19, 19. You know, if you do that, though, it might not add up to 100
Okay.
as well. If you round it off too much, it's hard to know. 8 and 11. Yeah, so this doesn't even round up to exactly 100%, but that's okay. So do you see my number here? Look at that. Based on my data, we'll talk it through with everybody when everybody gets back. So, what did you guys get for your value, for your calculated chi-square value?
We got 3.03.
Sounds more realistic. My data was too good. Look at this one. Look at this value here. Expected 22.12. That's a really good one, right? I mean, I just made up the numbers. So, and now you can go to your table and look that up on the 3 degree of freedom row this time, if you want to look ahead. Welcome back, everybody. Did you see my calculation, how it worked out here? You guys that just joined back? Am I sharing? Oh, good. I think if I go to your room and come back, then I'm no longer sharing. I figured that out. I just figured that out. I don't know why it took me so long. All right, ladies and gentlemen, let's, should we get everybody back? Let's help them out. Close all rooms. Hey, when I send a message to your room, does it just pop up on your screen at the top? Okay. All right, you have 30 seconds to get out of that room now. We're almost all back. Here we are. All right, welcome back, everybody. As you can see, I went and did my calculations, and maybe largely because of this value here, that I selected 22 just off the top of my head. And that's really close to the expected. So you end up with a really small difference. You square it, you get an even smaller number, and then divide by the number of units here, expected divided by this. You get an even smaller number, really tiny, right? So this just goes to show you if your data is close to your expected and your observed minus expected is really small, you're going to end up with a really small number down here, right? Which would happen if you got much more data, presumably, right? So the smaller amount of data you have, the greater your susceptibility is to like small fluctuations making a big difference in your chi-square value. Pretty cool, huh? So I mean, how many of you have actually taken a high school or college statistics class before? Statistics? Oh, Hannah, Sean, Malachi. All right, cool. And so is this familiar then to you guys pretty much? Yeah. All right, I hope I'm explaining well because I'm not a statistician. The kind of research I've done in my life of science hasn't really involved a lot of statistics. But so it's even helpful for me to think this through. I find it helpful and refreshing. So what kind of values did you guys get? Room 1, Lillian, Andres, Jay, what was your value down here?
Really large.
Oh, really?
I think it was, yeah.
How large?
It was 17.94.
Wow, and is it because
I'm gonna double check.
Is it because one of your differences was really large?
Yeah. Yes.
Which
first
one?
one.
The first one.
The wild type.
What was your data? What was your number expected?
We had 50 wild type and our expected was 68.65.
Oh, 50 and 68. Okay, so you didn't have as many wild type as you expected. Interesting.
Yeah.
Well,
but it was a lot more than the other ones. But I guess it just wasn't enough.
So the other ones were much smaller than expected. So that all of it added up to maybe your expected values were wrong. 9 to 3 to 3.
Yeah, I'm gonna redo the calculations and see if I get the same number.
We could just do one column together if you want. Anyone else? Anyone else have a number to share? What about room 2? Eden, Jordan, Malachi?
Our value was 1.27.
Ooh, pretty small. I can predict that you're going to be in the not rejecting the null hypothesis group. Okay, what about room?
We can.
Yeah, room 3?
We got 3.03.
There you go. That seems reasonable too. Since that was in the same range of the 1 degree of freedom of not rejecting, I think this will be even more forgiving. So I very much doubt you'll reject your hypothesis with that. What about room 4? Jean-Edward, you may not know what room you were in. Hannah?
We got 0.556.
Say it again?
We got 0.556.
0.55. Wow. You guys, are you sure you didn't fake your data and fudge it a little bit? Just kidding.
I'm trying to see like what.
No, that's good. That
was like, it does look really good. Very
close to expected, right? Which will happen a certain fraction of the time, right? By chance, you'll get a really close value. And this is why Gregor Mendel was accused of malpractice, because his numbers were like too good, you know? But probably what happened is he just stopped the experiment when he got the data that he needed, quote unquote. He didn't like He didn't decide in advance when the experiment will be stopped. I will stop this experiment when I have 300 observations, right? That is a better way than to just keep going until you get the result you want, right?
Didn't he keep going until the ratio didn't change very much? Till there was like very little variance in the ratio. Like he got so much data, I believe, that like
Yeah,
it was like in the
yeah.
hundreds.
He did have hundreds, lots and lots of data. Nonetheless, people questioned it, and because not all of them have the same amount, you can tell he did actually make a decision on how much to collect. It would have been better if he just decided in advance to get 600 Ps and get the ratio. So people have analyzed it extensively. Did you guys talk
Statistically,
about
it would make sense though.
Say again?
Statistically, wouldn't it make sense though? The more like data that he gets, the closer it would be to the value. I don't know why people would be skeptical.
Possibly, yes, but also you can do the precise calculation and figure out with this number of observations, what is the chance that it would be this close? And if you do that with all of his data, it turns out like by chance that would happen like 1 in a million times. You know what I mean? That all of the data would be that close to the expected. See what I mean?
Yeah.
And I don't, people don't think he actually faked the data. He just probably stopped the experiment at a particular time that he inadvertently put in a bias into his experiment. And his results are true and right, but it explains why his results are like too good, if you will. That's what people think. He was a man of God. I mean, he's not a cheater. He's not a cheater. Okay, so what about room 5? James, Sarah, James and Sophia. What was your number?
Yeah, it's pretty high.
Yeah.
It's 24.858.
Oh, it is high.
Yeah,
So
and that could, yeah, I don't know.
What are some of your values? What was your total, for example?
My total was 129.
129 divided by
it could have
16.
been screwed up because some of the really dark brown flies might have looked ebony, but
oh, okay. See, this is where you get your recognizing the phenotype errors.
Exactly.
Right?
And the
So
data really
not
got
a lot of. So categories 3 and 4 had lower numbers, bigger differences here.
Yeah, exactly. That's what ours looked like. We had we had way more ebony colored flies than we probably should have.
Interesting.
For especially actually for both of them.
So your wild type tended to be low, and your is it ebony or
well, the
black?
wild type was pretty spot on, but the other 3 values were like one was like the wild type vestigial was lower, the ebony normal was higher, and then the ebony vestigial was higher.
Okay. Yeah, okay. Well, you can analyze your data, but that it is what it is. You can't change it. So I would suggest then just doing the calculations. What we need to do now is go to the chi-square chart, right? So the chi-square chart, and now we're looking at row 3 degrees of freedom, and you can see that your value is even higher. It's higher than this. So you would expect that result less than 1% of the time by chance.
Yeah, I think we might have messed something up, so I think that's why or something.
That's okay. So I can see some of the groups have a number that's way down here, right? So their numbers are really close to, they're close to the actual ratio you would expect. You're not going to reject the 93 to 3 to 1 hypothesis, right? So go ahead and you can begin writing up that. Does anyone have a question about where their number would fit on this? On this table? Again, you notice the number is bigger, but yes, go ahead.
Can you explain, like, in general, how would we determine, like, the freedom, the degree of freedom to figure out?
Right. All it is remember you have four categories of data, 4 different kinds of flies. And basically the degrees of freedom is you take 1 away from that. So 4 minus 1 is 3 degrees of freedom. I wonder if it says that, if it explains it in here. Yeah, 2. So here it explains in this little paragraph where you have the 2 different categories, the data with 1 degree of freedom, 2 phenotypic classes minus 1. So degrees of freedom is the number of phenotypic classes minus 1, right here. It's right here. That's what that means. So you need, if you're going to use this table, you need to know how many categories you have, because again, if you have lots of categories, the numbers need to be larger to compensate for those extra things you're adding together. Did that help, Jay?
It does.
Oh.
Dr. Story, I have a question about the worksheet 2.
Yeah.
So it says, let me get it pulled up. It says experimental chi-square value, and then it says the chi-square value from confidence table. Are those 2 separate things, or are they asking the same thing?
So let's see. Your experimental chi-square value is the sum of this. You add it up, right?
Okay.
The lower right corner of your little diagram.
Yeah.
Right. So you can take that from the other chart and paste it in, or take a picture. Probably just paste it in. And then chi-square value from confidence table using 3 degrees of freedom, 96. This is from the let's look this up together. So 3 degrees of freedom, that row. 95% confidence interval. That's going to be the 0.05 column. So let's go back to that. So that's this 95% confidence interval for degree. It's 7.81. See that?
Oh, okay. Yeah.
So that's so therefore your value, you're going to compare your value with that value and say, okay, my value is smaller, so I'm not going to reject the hypothesis.
Yeah. Okay, that makes sense.
Yeah. And then you can figure out the experimental error situation. Nice. So make sure you show your work, make sure you explain this part clearly in your own words, because that helps us realize that you really understood it, you know? Minimize. I would recommend taking a look at this, you know, this background information, this Edvotech handout. It's kind of useful. It's kind of nice. Just had a lot of good information. All right. Next, this. Let me see, do I have? All right. Three-point linkage group reports. Use this template. Okay, so this template actually has some stuff to fill in. So we can move on if you like to, where are we? To the tri-hybrid mapping group report. You guys are gonna work together on this. One report per team, but we can get you started on this all together simultaneously. If you're ready to move on to this one, this is the second component of this. this lab, or the third component of the FlyLab, I guess. We did the phenotypes, crosses, we did the dihybrid, monohybrid analysis, and now the trihybrid mapping, which is, let me just say, very cool, very interesting. So there is a, go back. There's a sheet, right? I believe. Yeah, that's Carolina Student Guide. You want to have that open. All right. Carolina Student Guide looks something like this. Student sheet. And you want to have the group report sheet. That's a Word document that looks like this. So put in your team members' names right now. And I suppose, for simplicity's sake, you can just do it all together as a team. So your table of results. I don't know, did you all get that information at this time? Did you get it yet? Do you have the data? No, you don't have the data? Okay, so I need to give you the data. I think I emailed it out, didn't I? Trihybrid data. Let me see. Let me go to my email and see if I can find it. Trihybrid data. Sent. I think I sent it to you TAs, didn't I? Give me a second.
Let me check.
I have a picture of it, but I think I actually.
I think you
here it is. I have it.
I think you emailed it
Oh,
to
you
it.
guys. Yeah, I did. So here's the email. I'll put the data up on the sheet here so you can see it. So here it is. So the 8 phenotypes. Let me make this bigger for you guys. So the 8 phenotypes are in order as on the data sheet. So what you're going to need to do is sort of copy this in table of results. So I would recommend making a table here. So insert table. Oops, insert table, insert table. We have, we'll make it 9 rows and how many columns? 5 should be enough. Okay, so we have our table and you can adjust it a little bit. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that worked really well. 1, 2, 3, 4, 5, 6, 7, 8. And then you need to go and look at the sheet and put in the different categories. Here they are. So let's see. I don't know this. So do you all remember this? We did the counts, didn't we? We did, didn't we? Let me just see everybody here. Okay, cool. So I think the best way to do this is whoops, b plus wild, whoops, little b plus b space bg plus wild type bw plus. So that's one of the parental phenotypes. No crossovers, no mutation. That's a wild type. Gray body, which is the normal wings, not vestigial wings, normal wings, and red eyes, wild type for eyes, not brown eyes. Remember the brown eyes? Yeah. Then the other parental phenotype was black body, vestigial, black body. Wow, it's autocorrecting. It's such a pain. Stop autocorrecting. VG and BW. brown eyes. So that's a parental phenotype. This is a parental. So far, did you guys understand the concept? What was mated together was a triple mutant fly, right, with a wild type fly. And so we have these 3 mutations. Let's talk about another possible offspring, which be number 3 is B. B, undo automatic capitalization, VG wild type, and BW wild type. This is a crossover between the B, a crossover between the B and the VG. Dang, stop capitalizations. And the other possible crossover between B and VG gives you the other kind of fly, which is B plus, little b plus. Oh, this is super annoying. And VG and BW. So brown-eyed, black-bodied fly, gray-bodied fly, wild-type body, vestigial wings and brown eyes. Single crossover. Are you guys following along here? This is kind of fun. James is not following along. Do you see this handout? Do you have it handy?
Yeah, there's like 6 different handouts I have open right now.
Well, you should close the other ones and just like minimize them, and just all you need is the Carolina student lab sheets, 3-point linkage. It's
Okay.
Carolina sheet. So what we're trying to figure out is what the crossover frequency is between these 3 different genes that are linked. All right. Crossovers are going to give you these non-parental phenotypes. Double crossovers, right? And so we have body color, wings, and eye color, all these various different kinds of flies. And we counted all these flies and we have numbers. The numbers are, we're going to fill in the numbers shortly, but right now I'm just reproducing this chart so you can think through what are all the different kinds of flies we're talking about here, right? There's 8 different possible types of flies. And 2 out of the 8 are just the normal parental, no crossover fly, results phenotypes, right? This is a parental phenotype, this is a parental phenotype. And then you have your single crossover phenotype between black and vestigial. And then there's another kind of crossover between vestigial and brown eyes, vestigial, which give 2 different kinds of flies, which is the gray body, which is wild type body, normal wings, brown eye, or the black body, wild type wings, wild type eyes. Wait, did I do that right? Normal wings, brown eyes. Oh, yeah, 2 normal wings and a brown eye, or a black body, mutant wings. It should be vestigial wings, and wild type eye. Yeah. So let's see. This is wild type, mutant. This should be mutant, mutant, wild type. Because the crossover occurs between the wing and the eye. Very confusing. So this is over here, we can draw this out. It's B plus, VG plus BW, or B VG BW plus. I don't want to auto capitalize. Don't want to auto capitalize.
What is the BW again?
BW is the eye. It's brown eyes or red eyes. So red eyes equals BW plus wild type. Brown equals BW. So brown eyes is abbreviated, not BR as you might expect, it's BW. Brown. What do you think, Joe? Is this kind of tedious? It's a little tedious. Somebody had to do all this, figure this out.
Yeah, a little bit tedious, but it's necessary.
It's necessary so you can
complete the
understand
lab.
what's going on, right? All right, and then the
Yeah.
final is going to be where the flanking ones are the same in the
I
middle.
have a
one-
question.
Yes, question. Yeah, go ahead.
Where are we putting this in our lab?
So this is in your Fly report of gene mapping. So this is a Word document that's under Canvas. It's assignment tri-hybrid mapping right here, 30 points group report.
Jay, I am writing it all down and keeping track of it because isn't it submitted as a group?
It is, but it's good for everyone to try to do
Okay.
it so you all understand it. You know what I mean? If you were in the room, you could all be like working together on it, but I'm doing it in time with, hopefully you guys are also doing it together. We're all doing it sort of together. But everyone's gonna have the same data and figure this all out. So do you see where you get that from? This sheet is it's a Word document that you download from that thing on Canvas. From here, tri-hybrid mapping group report. It's right here, this template. All right. Back to this. Okay, the last two are double crossovers. And it's B plus. I'm just gonna copy this to make it easier. Copy. Whoops. And there. Those are the two possibilities where the crossovers occur between two of the different genes, right? This is wild type body, pitch wing, wild type eye. This is black body, wild type wing, vestigial wing, brown eye. Wow. Okay. And then the numbers. So hopefully you have these numbers handy. Let's see, here they are. 140. 140 of those flies. 47 of these flies. 39. 45. 54. 40, 12. Wow. We have data, you guys. So that's what you need. That data. And then the next step is going to be to use this kind of a table here to do the calculation and do the map distance. So to get the type of crossover between black and vestigial, you're going to add together any of them that have black and vestigial crossover. So category 3, category 4, and then 7 and 8, because these also have black and vestigial crossovers, right? So you add up those 4 categories together, and you fill that in. Total of classes divided by total counted. So yeah, we have a little math to do, you guys. We have to figure out what percentage of the time there's a crossover out of the total together. Does that make sense? So, ooh, wow, look, you can actually fill this in. I didn't realize you could fill these numbers in. There's a little, it's editable. Seriously? Testing. Okay, so it's an editable thing. Well, that might be good. So I'm going to add these together. 3, 4, 7, and 8. 39 plus 45. 39 plus 45 plus 40 plus 12. 136. Total of classes divided by total counted. Oh, the total flies counted. I forgot to put that math down. It's in my email. 417. $136 divided by 417. Whoops. 3. That makes sense? How are you guys doing? Joe, stop me, and Sarah, stop me if I'm screwing this up. Is Sarah still here?
No, it looks good. Sarah had to leave to go do something.
That's fine. What's the percent crossover? You guys getting this calculation?
So should we make that table on our sheet, or?
What I'm going to do is I'm going to suggest you like copy and paste it in.
From the
Carolina document. This is the Carolina document.
It won't let me edit the document.
It won't?
No.
Huh. Well, then you can just type in, you don't necessarily need it. You can make your own table, or you could just make it in words and say we added together categories with crossovers between black and vestigial, and they add up to this, which is this percent. You know, you could just write it out like that. So let's do 5, 6, 7, 8, add those up. So that's going to be, whoops, 5, 6, 7, 8, 54, 40, 40, 12. Divided by 417. 0.350. Whoops. times, forgot to write down the number, 146. Wow, I don't know if this is right. Interesting. So 35%, 35.0%. To determine which is in the middle, look at the phenotype of the double crossovers. Which phenotype has switched from the parental? This identifies the locus that's in the middle. So what locus is in the middle? What do you guys think? Oh. Can you tell me which locus is in the middle? Oh boy. It's vestigial, you guys. Wild type vestigial. So look, see this? Wild type vestigial, wild type. Mutant vestigial, mutant wild type, mutant. So it's the vestigial is in the middle actually, right? VG. Whoops. That's interesting. It's not letting me edit that one. And then you can actually figure out the crossovers between B, VG, and VG and BW, right? Can't we? So this should be B. So I would say on this one, so published, we need to find a published map. Experimental map would be B. Whoa, this capitalization is so annoying. B, VG, BW, right? Stop auto capitalization. So experimental map, and then this would be B and VG would be 32.6, 32.6, and this would be 35, 35.0, whoops, 0.0. And so that will be, those are the distances between these three different genes according to our data. Yes? Following that? There it is. That's it. That's all it is. That's all you do. But now we need to find a published genetic map. So I want you guys to go on Google or DuckDuckGo or Bing it and find a published map. So whoever can find that published map first, I want you to shout out and say, Eureka. All right, so go on Google and try to find a map of Drosophila, and it's called a linkage map. Fruit fly, I'm gonna do it on my left screen so you guys can't see it. I did it already the other day and I found it pretty quickly. So let's see if I can find that. Move it on my other screen here. I'll hide you guys a little bit. Okay, I'm gonna call this Drosophila linkage map. We'll see how well we did. Anyone find one yet? Eureka, found it again. It looks something like this. Did anyone find something like that? Yeah, Lily's nodding. She's Eureka. You're supposed to say Eureka. All right, so you should see something sort of like this. I don't know why this is a figure. Okay, so chromosome 1, check it out. Can you guys see this? This is really cool. Chromosome 1 is here. Chromosome 2, chromosome 3, and these little chromosome 4 right here. And so which chromosome are we on? You didn't figure that out yet? Check it out, black body, right there. Black body, and where is it located? 48.5. Oh, vestigial wings, 67.0. Brown eyes, 104.5. Beautiful. Are you guys excited about this? This is really amazing. We actually found it on here. So let's see. So what we need to do is maybe we can copy and paste that in. Let me zoom back a little bit here. Let's just a little bit. Really, I can just do the this little part here and put that into my Word document. And it's a little large, so I'll shrink it down a little bit. Whoops. Hate it when that happens. Okay, so and I need to cite my source here, copy this, Biocyclopedia. And here we see the linkage map distance R, and we would say between B to VG is, we do a little math problem, we figure that out, and then between VG to BW is, wonder why this is like an old thing. It shows brown eyes as L instead of BW. That's interesting. Don't know why it's L. Oh, L. Like these both have a weird. It's like they made a mistake. Lobe eyes maybe is L. Dominant. See, the big capital letter means dominant. Brown eyes should be BW. This is a mistake, I think. Let's see. Maybe this isn't the best source. Maybe there's a mistake on this one. So escape out of here. Go back. Linkage map. Dang, this thing keeps appearing over there. Just off a linkage map. Let's try this one. Oh, geez. Yeah, see here, BW. This is much better. This one. I wish it was a higher resolution image, but it's not terrible. Oops. And we have, what was it? It was vestigial, was in the middle. Oh, black body, right? Okay, let's go back to the Word document again and put this one in. Okay, black body 48.5. Okay, that agrees. Vestigial 67. Okay, that agrees. Brown eye, this time it says BW. So I'll go back and I'll get the source for this one, which really isn't the best source. It's just some question and answer homework question. But this clearly looks to me like it was taken out of a textbook or something. All right, let's pause for questions. So what you need to do is basically talk about your results. Like, how does your experimental map agree? So vestigial, brown, do the subtraction from above. And so let's see, how close are you? 104 minus 67. 104 minus 67. 37. 37, what did we get? 35. Not bad. What about black body and vestigial? 48.5 and 67. 67 minus 48.5. 18.5. Oops. Not good. I think our data is not exactly, the published linkage is 18.5. And this one is, what was it, 30-7, I think, 37? Don't quote me on that. So 35 was close. This one seems to be, we got a high number here. So the B veg numbers are added together. 3, 4, 7, and 8. So somehow we got two high values in these categories. Interesting. Do you agree? That's it. Any of your thoughts? You guys can unmute and chat at this time. Ask
Are we
questions.
supposed to be filling out the Carolina sheet as well?
No, you can. What you could do is, I was thinking you could do is you know, copy and paste some of that stuff in, but you can just reproduce this in your own report.
Okay.
So like our linkage based on data, you know, you can somehow reproduce this or just type it in. But these are the numbers that we got. So, you know, you can write it out like to get the crossovers rate linkage between B and VG. We need to add up all the classes that include these, which are right 3, 4, 7, 8, 3, 4, 7, 8 above table. Now, so 3, 4, 7, and 8, right, are the ones that have the crossover between B and VG. So you're just typing that out in words. Don't just copy what I wrote, you guys. But you get the concept of it? You add those up out of the total number of flies. How many of those flies had that crossover between those two? Let me go back to this. How many of those flies had a crossover between this one and that one, right? And then you add up how many flies had a crossover between this one and that one. So it includes the single crossovers as well as the double crossovers, right? The double crossovers are the last two rows, and the single crossovers are the ones between these two. So that's why it's in the table. That's why it's where's the table here? That's why it's either these two plus the doubles, or this two and the doubles. Comprende? You got me? Catch my drift? All right. Jay's like, oh, I should have gone to bed earlier. Seriously, take my advice. I'm gonna let you guys go in teams now again and just discuss, all right? And determine how you're gonna turn this in, whether you're gonna share it with each other, email it, do whatever. So I'm gonna open up the rooms again. This will be the last one probably, and we'll be done. So go ahead and join your rooms, commiserate, figure this out, talk to each other. Yes, I did fix that. Sorry, it was an error with the syncing system. So I went in individual and had to change it in each of the sections. Check it now, period. Hey, Bethany. Hey, Bethany, exclamation point. I was just about to send you an email, period. Yes, we're on for 5 p.m. and I think it's fine for you to talk about your science, and I will slow you down if I feel like you're going too fast or whatever, and maybe ask for clarification and stuff. I think it'll be excellent, period. I want students to think about ways they can use their scientific background to, study diseases. And now that everyone's thinking of infectious disease, maybe this will be more real to them. I will email you the Zoom link. Yes. You guys good?
I don't really have a set group that I'm actually in.
Oh, really?
Yeah, I was under cautionary hold for the first part of this lab. And so my original group was put with another group, and I was out. Right. And
so I just put you in a group just now, though, right?
Yeah.
So you should just go with that for this lab.
Okay.
Whoever you were just with is fine.
Okay.
So they're gonna put your name on the submission. It's gonna be like one submission per group.
Okay.
What's your last name?
Hale.
Hale. And so is James in your group?
Well, the one you just put me in. There's another Sophia.
I didn't realize I was muted.
Hi, Dr. Story. I'm supposed to leave this afternoon. I really need to figure out like the last details. But but the document's been shared and everything like that, so I think it's all set.
So we're almost done. We're really almost done.
Okay.
Just hang out for another like 5 minutes.
Okay.
All right.
That works.
I just told everybody to rejoin the group. Olivia, where are you headed to?
I'm going home.
I mean, where is home?
Oh, Connecticut.
Oh, Christmas in Connecticut. Have you seen that movie?
Nope. I have not seen a lot of movies.
Well, Christmas in Connecticut is a very old film. So you got to watch it. You'll have plenty of time. You're not taking any winter classes, are you?
Yeah, I don't think so. No. I was thinking about it, but then decided not to. I think I'm gonna do one in the summer though. Yeah.
All right, let's see. Everyone should be coming back. Let me close them and force them out. I'm gonna force them out.
32.
I'm second guessing the group submission aspect. I'm wondering if we should just each one should submit the one, but one person could like make it and share it. I don't know. Actually, I think a group should be fine because the TA's graders can just basically see who submitted what. All right, we're all back. Are we all back? Did we lose people? No, we're all here.
Olivia had to leave.
All right. So did everyone figure out what they're going to do for this group assignment? So as long as one person each team submits this, you should all get the credit for it. Are there any final questions on how that linkage business works? It sounds really complicated, but all it is just figuring out what percentage of the time out of the total crossovers occurred between this and that, that linked gene. And the closer they are, then the less crossovers there are, and it's a physical map of the actual chromosome. It's just like a mind-blowing idea that you can actually do this, by looking at fruit flies. So there's one more assignment in Canvas. Hopefully you guys all saw that. Did you all see the quiz, the DNA transformation quiz? I'll send reminders and stuff. But that's pretty much it. I was gonna do a DNA gel loading quiz, but that didn't happen. So we'll figure out a way. You'll be doing that sometime in genetics at least. Final questions, anybody? You feeling good? Somebody said they thought it was explained well. Hannah, something was explained well. Well, I'm very happy to hear that. Is she here still? Hannah's gone.
She had to go.
It's a bummer. All right, ladies and gentlemen. Yeah, let me know if you have any difficulties. I'll see some of you on Friday for the coronavirus lecture, which I will post on. I'll be posting the Zoom link for everyone. And I think Dr. Zhang's catching up with viruses. We finished viruses. We are in Dr. Zhang's class. So we finished viruses on Wednesday, but we're going to talk about coronavirus. So I'm looking forward to putting that together tonight. It'll be fun. We'll see how it comes out. I'm going to be talking about some of the published results, some of the recent results, like the spike protein in motion, stuff like that, stuff that you might not know about.
I think our classes are always like a little bit behind.
Not always,
yours.
ever since genetics.
Oh, okay.
He did a lot more genetics problems, I guess, and got a day behind somehow. So
yeah,
I tried to stick with the syllabus, but I think you'll get caught up this week. So yeah, very good. All right, thank you guys. That was kind of fun. Olivia's got to go. She's got to go to Connecticut. All right, we wish you all the best. Be safe out there, and be aware that there is a deadly pandemic, which is only deadly for a certain fraction of the population. And for those people, we need to take care to avoid it. You guys are lucky you're in the usually healthy group, but not always. We'll talk about that in the next lecture as well. What fraction of people get sick and this kind of thing. Long haulers, theories on what's going on. We'll talk about biology of coronaviruses, so that'll be fun. Right on. That was fun for me. I enjoyed that. See you, Jay. See you, Malachi.
See you guys.
Peace.
Bye. Thank you, Dr.
Bye.
Story.
Thank you.
All right. God bless you guys.
See you.
You as well.
Overall, over and out.
Dr. Story.
Yeah.
So I was just really wondering, I came back to talk to you just to like get the last of the data from what you were doing.
Oh, you mean the data on the crossovers?
Yeah, so like I was just wondering, just that I can understand, just because I was a little confused of
Like this data right here.
Yeah, so I got that, and since I was doing that instead of talking to my group, which by the way, my group isn't even here. Sophia's Escoda isn't here, and then Bella's computer died.
Right, which is why I'm recording this. So
right. Oh,
watch
okay.
and figure it out.
Oh, good. Okay.
Mm-hmm.
So I was just wondering if you could like quickly explain that to me, like the crossover percent, and like just so that I can like sort of understand the ending of this lab. If you have time.
Oh yeah. I mean, so it's something that's in the textbook. And I don't have my textbook here, it's at home, but it talks about how do you determine the distance between any two genes, right? What you do is you take a mutant fly, which is mutant for these linked genes, and then a wild type fly, and then you look for non-parental phenotypes. So these two phenotypes are like the parents. The parents were this genotype. Oops, you're not seeing that. Sorry. The parents, well, this is the answer key. I'm showing you the answer key. The parents were this phenotype or this phenotype. They were either mutant, or right, whether wild type, or mutant, right? Anytime you have an offspring that is not like the parents, it means there's a crossover between those genes. So for example, if you have a crossover between the body and the wing mutants, then you get a mutant body with wild type wings and eyes. Or conversely, you get, and this is probably from maybe the same meiosis event that occurred, excuse me. You get the wild type body with the mutant wing and eye, right? So these two are crossovers that occurred between excuse me again, the body and the wing.
Bless you.
Body and wing, body and wing. These are, and so those are the crossovers that occur between body and wing, which is here on this schematic, which is the general schematic. This one plus this one, which is a double crossover. So you have the crossover here and the crossover here. So that includes this includes a crossover between the first two.
Yeah.
As well as this one. So that's why you're adding together the BVGs as well as the BVG VGBWs. You're adding together 3 and 4, these two numbers together with these two numbers.
So if this is the answer key, what are the numbers that you gave us
The numbers we
before?
got are off. They're off. So
Oh, okay. So
you're
that's
just
what it
not-
should look like
this
if it
is
was perfect.
like an ideal. This is some data that they got. And
Yeah.
this is the numbers that they got.
Oh, okay. Okay.
Right. So our data was not as good as their data. It's always off. It's always a little bit off.
Right. Yeah.
But I
there's
was
a-
happy to see that one of them was within the ballpark, you know, of the published.
Sure. Yeah.
Does
Okay.
that sort of make sense now?
Yeah, I think so. And so this sheet, all we're supposed to have on it is, of course, our names and our lab date and time. The
Yeah.
table of results, the genetic maps with the
And then a discussion.
source. Okay,
Discussion
and
of
then
the
the
result.
discuss.
Yeah.
Okay. Yeah. Um, I guess
Yeah. So you're going to be talking about in the discussion how, you know, the vestigial brown, was it the vestigial brown that was close to the expected value, published value, and you have to do the math and figure out what the brown vestigial 67 104 minus 67. You know, just compare that with the published value, and then comment on it and say, like, think about maybe why it might have been off. So what I would
Okay.
recommend is if you have other people in your group, just maybe email them that discussion and say, what do you think of this? This makes sense to everybody. Work as a
Okay.
team a little bit.
Yeah.
Yeah, and you
And
have a little time before it's actually due. So